Hello everyone, welcome to another video. In this video, I will talk about how we can plot two-dimensional functions in Mathematica. There will be more videos in the upcoming weeks on plotting, like plotting two-dimensional functions or plotting different kind of equations. So let's get started. Say we have a function f of x equals to x squared. So to plot this function, we have to use the plot command. Write plot, and inside the square bracket write f of x comma, and we have to specify the range of the argument. So the range of the argument is from -10 to 10. So this is the graph. We could also use x squared inside the square bracket. We would get the same result. Now remember that the plot function only takes input on x-axis and gives output on the y-axis. So you cannot plot a function of y directly using this plot function. You have to change the function and write the function in terms of x first. For example, let's take x equals to y squared. So y is already defined. As you can see, y is in black. So let's clear y first. If you want to directly plot this function using plot function, say you want to write y squared inside plot, well, you have to give the argument also. So we have got the same graph. You can see that the Mathematica is taking y on x-axis and giving the value of x on the y-axis. So we cannot plot x equals to y squared using plot function. So to plot x equals to y squared, you can write y in terms of x first. Say here y will be square root of x and negative square root of x, and then plot these two functions using the plot function. I will show you in a few minutes how you can plot two functions in a single graph using plot. But for now, let's take a new variable, say function 1. Here I am not defining any function, I am just writing a new variable, function 1 equals to a e to the power negative x by a sine pi x. This is the expression of damped harmonic oscillator. Here a and small a are constants. So let's try to plot this function. Negative x divided by a and then sine pi x. So again, write plot, and inside plot write the expression. We can just write function 1 here. So we cannot keep constant a and small a inside plot. So let's replace the value of capital A and small a. So use the replace sign slash full stop and take a equals to 10 and small a equals to 5. We'll have to keep them in a list. Dash and greater than sign to write the arrow and keep them in a list, and then give a comma and specify the range of x. Say x, I want to take x from -10 to 10. Well, it's a damped oscillator, so take 0 to 10 because x is time here. So here is the graph of damped harmonic oscillator where x goes from 0 to 10. Now let's try to decorate this plot by adding some plot options. So give a comma and then we can add some parameters, like we want to add axis label. I'm just going to the next line, pressing enter. You can see that this expands the cell. Let's write a comment here inside the square bracket. To write a comment, you have to give parenthesis and asterisk sign and write the comment. I want to write plotting options, and then again give the asterisk sign and parenthesis to close. We are still inside the square bracket, So let's add some option. Say I want to label the axis x and f of x. So write axis label, we'll get the option. And if you choose automatic, they will give x and y, but I want to take specific x and f of x in the y axis. So keep them in a list, x and f of x, and also keep them inside the inverted comma. So if we press shift enter, we will get the labels. Well, I didn't close the list here. So as you can see, we have the axis label now, x and f of x. So let's add another option now. Just give a comma and go to the next line so that this doesn't get messy. Now I can go ahead and label the plot, write plot label, and you will get the option. And say I want to label it as plotting 2D function. So write plotting 2D function. And keep this inside the inverted comma. So we can see the label. Now give a comma and go to the next line. Well, I mistakenly pressed the shift enter. So let's delete this cell. Select this cell and press delete in the keyboard. Let's go ahead and add plot style now. Go to the next line and write plot style. Let's choose dashed from here. So if we press shift enter now, we'll see the dashed line. Also, we could change the color of the line. So go to the plot style again and give a list, and inside the list write say orange. Keep orange and dashed inside the list. And now we can see the dashed orange line. We can also change the thickness of the line. Just add thickness, it's a function. So inside the square bracket write 0.02. Well, it's a bit thicker than I expected. Let's take 0.01. So we can change the thickness a bit. We can also vary the range of the function. We can specify the range of y like we have specified it for x. So let's take another function because the range of this function looks fine. Let's go and set a variable function 2. Say the function 2 equals to e to the power x cosine of x, e to the power x cos of x. So let's plot this function now. So let's take function 2 inside plot. So if we press shift enter now, we see the range. So Mathematica tries to be intelligent about how it sets the axis. Sometimes you may get graph quite zoomed in, or sometimes you may get huge range like this. Let's take e to the power sin x and let's see what range we get. So we get from minus 2000 to 4000 for e to the power x sin x. Now let's change the range of this function. To change it, you have to use plot range function. So give a comma and add plot range. Say I choose full. You can also take automatic. Let's see what happens if you choose automatic. Also, you can specify the range. Say I want to see the range from minus 10,000 to plus 10,000. So you have to give a list. minus 10,000 comma 10,000, and you get the specified range. Now let's try to plot multiple functions in a single graph. So let's go ahead and write in the text mode. Well, let's write adding multiple functions to the same set of axes. Let's add some more functions now. Let's take function 3 equals to a e to the power minus x divided by a. It's the same function 1 except the sin pi x part. Let's just copy and paste this part. And let's take function 4 equals to negative a e to the power minus x divided by a. Now let's plot these three functions in a single graph. So to do that, you have to give a list, and inside the list write these three functions, the three variables. Also, you have to replace these values a and small a. Let's take a as 10 and small a as 5. Now we can delete the plot range part and keep all other options here. Well, I don't have function 2 right now, so this should be function 3 and function 4. So if we press shift enter now, we get the graphs. Now I don't want to see the graphs, the lines as dashed lines. So let's change the dashed thing to thick. So you get thick lines now. Well, also we cannot tell that which graph is which. So I would like to add some legends to the graph. So to do that, you have to write plot legends. And let's choose expressions. Well, you cannot see the expressions because I took functions which have constants and I replaced the constants by some numbers. Let's just define the constants at first, and let's not just replace them using the replace sign. Then I can hope to see the expression. So hopefully we'll see the expressions now. So you can see that the orange, so they're using orange in both because I used orange in the plot style. So now we can see three different colors specifying the three different functions, and we can tell which function is which. Also, there are some drawbacks of plotting multiple functions in a single graph. Say I cannot choose different domains for different functions. The domains of the functions must be the same. Also it's difficult to control the plotting style. Say I want dashed line for a single graph and thick line for another graph. I cannot do that. To fix that, we have a function called show function. So let's see how we can use that. So now let's plot two different functions for two different domains. Let's plot x cos x first. say x varies from 0 to 4 pi. Give a comma, and in the next line let's take a plot style. Say let's take orange dashed line. So plot style arrow, and inside the list I write orange comma dashed. Here is the graph, and let's plot another function using plot function. Let's plot 2 sine x minus pi by 2. And now x varies from 1 to 3 pi. And now let's take the line as green line. So let's choose plot style green. So if you press shift enter now, you get the second graph. Now using show function, I can show these two plots in a single graph. So let's give semicolon at the end of these two plots, because I don't want to show the outputs of these two graphs. And also set two variables, plot 1 equals to the first one and plot 2 equals to the second one. Now let's write show, and inside show just write plot 1 comma plot 2. And there you go. Also we can add plot options inside the show command. So let's keep plot 1 and plot 2 inside curly braces. And then let's add some plot options inside the show command. Let's just add axis label and plot label. Let's copy paste it from here. Let's change the plot label. Let's write multiple plots using the show. Well, I forgot a comma. After plot 2 there should be a comma here. Also there shouldn't be a comma at the end. So now I should see the graph. Now to add legends to this graph, I won't use plot legends. Instead I will write legended and keep the whole show function inside the legended function. Now I have to add some legend options here. So let's go to the next line and write a comment. Add legend information. So the argument that needs to be passed to this legend command is a type of legend. So I'm gonna use swatch legend here, and I can see so write swatch legend. So I can see that I can make a orange swatch and a green swatch. So write orange and green inside the curly braces, and what I can do here is I can label the first one. The orange may be representing the temperature and the green representing the population. Also keep them inside the inverted comma. So what I'm doing here is I'm keeping the whole show function inside the legended function, and then after giving a comma I'm adding the legend options. If I press shift enter now, I can see the orange dashed line is representing the temperature and the thick green line is representing the population. That's all for now. See you in the next lecture.